Hello learners, welcome back to the video series on number system. In this video, we are converting numbers in other bases to base 10. So we have more than one method of doing this, and this video we are going to learn only the first method. So please watch out for the next video in this series where I will be explaining how to convert numbers in other bases to denary numbers using another method. So this first method is called the expansion method. Step 1, in a parenthesis is a bracket basically. So in a bracket, multiply each digit by the base, then put a plus sign between the parentheses. Then from the extreme right, insert an index on each base. Insert an index on each base starting from 0. So let's start with the first example here. We have 1101 base 2. So according to the method in a bracket, so let me open a bracket, multiply each digit by the base. So let me take this first digit here, this 1, then multiply it by the base, right? The next digit 1 multiplied by the base 2. The next digit is 0, 0 multiplied by 2, and the last digit is 1, 1 multiplied by 2, right? Now, after doing this, we are asked to insert a plus sign between the brackets. So plus, plus, and plus, right? The next thing to do is to insert the index, right? So we are going to start from our extreme right. So please remember that we are inserting the index on the base, right? So we start from 0, 1, 2, 3. So that means if we have other brackets to the right, we'll continue with 4, 5, and 6, and so on. So now we are going to solve. 1 times 2 to the power of 3 is 1 times 8. Plus 1 times 2 raised to power 2 is 1 times 4. Plus 0 times 2 raised to power 1 is 0 times 2. Plus 1 times 2 raised to power 0 is 1. So in the first part of this series, I emphasized how important it is to remember that any number or variable raised to the power of 0 is 1. Many times that I've seen students make mistakes, particularly in this topic, is writing 2 raised to power 0 is equals to 2. So that's where most students make mistakes, right? And also multiplying the base by the power. I mean, in this example, we have 2 to the power of 3, which is 8, not 6, right? So please, while solving questions in number base, these are the things that you should take note of. You are multiplying 2 by itself 3 times. So that means if we have 2 raised to power 5, you are multiplying 2 by itself in 5 places, right? So please take note of that. Let's proceed with our solution. 1 times 8 is 8. 1 times 4 is 4. 0 multiplied by anything is 0, right? Then 1 times 1 is 1. So 8 plus 4 is 12. 12 plus 0 is 12. 12 plus 1 is 13. That means the equivalent of our question right here is 13 base 10. In the second example here, let's start with the first digit. We open a bracket, right? 1 times 2. Then the next digit, 1 times 2. The next digit is 0. 0 times 2. The next digit is 1. 1 times 2. The next digit is 0. 0 times 2. And the last digit is 1. 1 times 2, right? Then we insert a plus sign. So plus, 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 and plus, right? So the next step is to do what? Insert an index, starting from the right and starting from 0. So 2 raised to power 0, 2 raised to power 1, 2, 3, 4, and 5. So let's proceed. 2 raised to power 5 is 32. That means we have 1 times 32 plus 2 to the power of 4 is 16. 1 times 16 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. So that means 32 plus 16 plus 0 plus 4 plus 0 plus 1, and that will give us 53 base 10, which means that the equivalent of 110101 in base 2 is 53 as a denary number. Another example here, we have 11100 base 2. So the first step is to open a bracket and multiply each digit by the base. So 1 times 2, another 1 times 2, another 1 times 2, then we have 0 times 2 and 0 times 2, right? So afterwards, we do what? We insert a plus sign. Lastly, we insert an index, right? Starting from 0, 0, 1, 2, 3, and 4. So 1 times 2 to the power of 4 is 1 times 16 plus 1 times 8 plus 1 times 4 plus 0 plus 0. Because I know that 0 multiplied by anything is still 0, right? So that means we have 16 plus 8 plus 4, which is 28 base 10. So in the previous video, I mentioned that there are ways you can confirm your answers when you convert from base 10 to another base. So this is basically how you can confirm your answers, right? So if you have a question in your exam or test or your class exercise that you're asked to convert from one base to another, so you can easily just confirm your answer roughly by converting that base back to your question. So if whatever you get as your result is equivalent to what the question is, that means you've gotten it right. Do you understand? So that means let's use this last example, right? We converted 11100 base 2 to base 10 and we got 28. Let's confirm if 28 is truly the answer. How do we convert from base 10 to other bases? We do a successive division, right? So we have 28 and 2. 28 divided by 2 is 14, remainder nothing. 14 divided by 2 is 7, remainder nothing, right? And 7 divided by 2 is 3, remainder 1. 3 divided by 2 is 1, remainder 1. And 1 divided by 2 is no longer possible as a whole number, so we write 0, remainder, the last quotient here, which is 1. So that means 28 base 10 is equivalent to 11100 base 2. So you can see clearly that we are correct because this value we just got when we converted 28 to base 2 is what the question is originally. So that's one way you can confirm your answer. When you convert from one base to another and you really want to be sure if your result is correct, just convert that same answer that you got back to the question, back to the base in the question. If your results are the same, that means you've solved correctly.